Welcome to software engineering classes. My name is Sandhya Rekha, Assistant Professor, CSE Department. So let us start the topic, Fundamentals of Software Engineering. So we'll see the first of all the session plans, the basic introduction, see the fundamentals of software introduction part, where we have divided into some divisions. The first module is about evolution, where we'll discuss about from an art form to an engineering discipline. I have decided to divide this into 3 sessions. Session 1, where we discuss about evolution of software engineering, where from art to engineering, then evolution patterns for engineering discipline, and addressing the software crisis. Then later on, we'll discuss about software development project, exploratory style of software development, emergencies of software engineering, notable changes in software development practices, and computer system engineering. So this is all about Unit 1 introduction. So let us start the first part. So before going to start the basic thing of software engineering, first of all, let us know what is meant by software. So software is a development or a process which will take some n number of steps from planning to execution, where each step involves so many technical things. Okay, so in order to develop a software, it is not a simple task. Like it is not an overnight development. So in order to development end product, we need some n number of steps to be performed. Okay. Now, I'll see what is the approach, what is the software engineering approach to develop the software. So, normally, before going to study what is exactly the software engineering principles, we should see the evolution from where it has been started. So, going to the evolution, it's a history about 60 years, back 60 years, how the evolution was started. Okay. So, I can explain this with an example where with a small example, like how a contractor can build the building like here. Now, if I am talking about a PT contractor and a contractor with a technical knowledge. Okay. Now, a PT contractor can be able to build a simple wall without any technicality. Simply, he know that how to mix the sand and how to mix the cement and all. Okay, he can simply build a wall. But when it comes to build a building with from 20 floors or like 30 floors, he will not be able to do it. Only a civil engineer can plan for that. Okay, so if at all he will take that contract also, he will be failed. That is the basic thing. Why he will be failed? Because he may be having the experience, but technicality may be lacking for him. So technically, he is not prone to develop the total process. So in order to develop this type of building, he need to have some technicality knowledge. Okay. Now, coming to this systematic collection of past experience, which contains techniques, methodologies, and guidelines. So this, whatever I am talking, this type of building where a civil engineer can build, it is not done by overnight. It requires so much technicality. Okay, so which may be acquired from the past experience. A civil engineer who is like a fresher may not be able to develop such type of building, but he need to have some experience to develop this type of building. So, in order to, when I am talking about software also, we need to have some experience. So, past experience is essential in order to develop a software process. Okay, the techniques, the methodologies and guidelines. Techniques are the technicalities, and the methodologies, what are the different types of methods to be followed, and the guidelines. Everybody like who are developing the software should need to follow some guidelines. Okay. Now, coming to the chapter outline, evolution of technology with time, then relatively changes of hardware and software cost over time, exploratory program development, increase in development time and efforts with problem size, human cognitive mechanism, data flow models of a car assembly plant, evolution of software design technique, and computer system design. So these are all the technical things where we are going to study about in the first unit. Okay. Now, we'll see the overall process of software engineering. So, how it has been started. Means, I'm talking about evolution, I'm talking about evolution. But the end thing what we are going to discuss is entire plan of the software engineering. How you are going to do the process. Software engineering will started initially with the planning. Planning is very important. Already I discussed about the construction of the building, where a civil engineer will plan a blueprint. So without a planning on a paper, it is not possible to design to build a building. In the same manner, in order to develop a product or a project in a software, we need to have some planning. Then after planning, you have to have the analyze the planning. Then software development, implementation, programming, designing, software testing, validation and verification. These are all the different steps should be involved. So these steps together, they form the entire process. Okay, so this is very important in order to develop a software project or a software product. Now, coming to the IEEE definition, they defined like software engineering is the application of a systematic, disciplined, quantified approach to the development, operation and maintenance of software. That is the application of engineering to software. Now, IEEE standards, they define that software engineering is the application of systematic, second one is disciplined and quantifiable approach to the development, operation and maintenance. So development is the first thing. Then after development, then the developed project has to be in an operational manner. Then after it has been in operational phase, then the next stage is the maintenance. Maintenance is what? Where you are deploying the entire project and you are making it into a live, where it will be in a live position when it is in operational stage, and when it will be in the maintenance stage when it is in a executional process. Okay, so these three are very important for the software development process. So they are saying same thing, like software engineering is the application of systematic, second one is the disciplined, quantifiable approach. The approach should be quantifiable, and for which it should be quantifiable for the development, operation and maintenance of the software. So just developing a software is not the end thing. After developing the software, you have to maintain it. It should be in an operational manner and it should be in a maintainable manner. That is application of engineering to software. Then this is all about how you are technically you are defining the engineering principle for defining the software. Okay. Now, is the software engineering a science or an art? See, we have to study, as I already told you, like we have to study about the total evolution of 60 years past evolution, where they have slowly developed the process. Initially, they thought of developing a project is just build and fix model, where you are building some part of the project, like generally students, all of you, like what you do in your academic programming subjects, where you generally what you will do, you write a program, then you execute the program in the laboratory, and if some errors are there, you just fix it. So this is a general process where they started developing a program. Okay. Now, here are the key components. First one is comparison with other disciplines. Now, first, before going for comparison and all the things, let me know first what is a science or an art. So, as I'm saying, like before that, software engineering is an engineering discipline. Now, I am saying that software engineering is a science or an art. You have to define it whether it is a science or an art. So, then we have to compare the comparisons with other disciplines. Like software engineering shares the characteristics with both engineering and science disciplines, but also has the artistic element. It heavily relies on knowledge accumulated through the experience of the numerous practitioners similar to traditional engineering fields. Okay. Now, in the traditional engineering fields, where I told you it is all about build and fix models, where you are building something and you are fixing. So, there are two things when I am talking about past 60 years of experience, there are mainly two things. There are only two types of programmers are there, good programmers and the bad programmers. Good programmers means they are having some experience, they will develop the product. Then the bad programmers who are like just following the good programmers, they don't have that much of knowledge. So I am talking about 60 years back, where the development was very slow. There is a lack of knowledge and generally experienced programmers who are very low in the market. So in that period, it was very hardly we can define the software engineering principle. Justly to develop a simple application, they are just gathering some programming knowledge and they are developing. And the bad programmers who are there, it doesn't mean they are bad, but they are just following the good programmers guidelines and good programmers knowledge. They are just sharing the good programmers knowledge. When comparison with other disciplines, like software engineering, when we compare with other disciplines like civil engineering or mechanical engineering, shares the characteristics of both engineering and science. This contains both engineering principles as well as the science behind how to develop the process, the technicality behind how to develop the process, but also the artistic elements. So, developing a piece of code, they are saying it is an art. Because art is like it should be come from the background, where when I'm talking about art in the past history, where our ancestors when a pottery pot when your ancestors are able to have that knowledge of making some pottery, then they will share that knowledge to their their grandchildren and all. So in this manner, they are, the artistic skills was carried on later on. So after particular period of time, this art has been converted into science. Okay, then what they have done, their children, they started developing some science in pottery making, like they have used that wheels and there's some mechanical things, some like not manually, some technically they have developed it, they make it as a science. Then later on, from art to science, they have developed into the engineering discipline. Okay. Now, software engineering also have some artistic, not only engineering and science discipline, but also should have the artistic elements. It heavily relies on knowledge accumulated through the experience of numerous practitioners. As I told you, it is not an overnight development. It has gathered all the principles, guidelines and the experience of the past information or the past programmers, what I said just now, good programmers who are having so much of knowledge they acquired by their experience. That numerous practitioners, similar to the traditional, like in other type of engineering fields, in the same manner, they have get the knowledge from the previous or the past experience. Okay, then next coming to the empirical and systematic basics. So past experience in software engineering have been systematically organized. Wherever possibility, theoretical foundation supports empirical observation cases where theoretical justification is lacking. Practical experience is used as a guideline principles. Now, whenever there is a empirical means what? Information gathered from the historical data, empirical data from the past experience. So whenever there is a lack in the past experience, means past experience have been systematically organized. I'm saying that past experience is systematically organized. Even though when the past experience is systematically organized, there may be a lack in the theoretical knowledge, okay, in the empirical observations. So this can be justified in where theoretical justification is lacking, then practical experience has been taken practically with the help of the guidelines and the guiding principles, which will guide for the development of the process. Next, scientific approach. When I'm talking about scientific approach, in contrast to rely solely on experience, scientific solution in the software engineering are constructed through rigorous and probable principles. Not only simply developing the software with the help of experience and scientific solutions, it also has been constructed through rigorous and provable principles. There are some principles which are designed in order to develop this software engineering. Okay, then handling conflicts goals. As with the other engineering disciplines, software engineering oftenly encounters conflicts goals during the problem solving. So when there is any problem, like they are not able to sort out, say in the part of like when we want to develop some small application, a banking application, where some conflicts may be there. Just I'm talking about past 60 years of evolution where they got some problems. So this banking application where there may be a problem. That problem can be rectified by following this systematic approach. So with the engineering discipline, software engineering oftenly encounters conflict goals during the problem solving. Okay. Next, multiple solutions are proposed and most appropriate one is chosen based on the trade-off such as cost, performance and feasibility. Cost, performance and feasibility plays a prominent role, where feasible study is nothing but when we develop a project, the project should be feasible. Means if I develop a project for 200 students, like college management system, when this 200 has increased to 2000, then my project should be in a position that it should be a feasible, so that the 2000 students data should be able to handle by my project. That is the feasible. Then that feasibility and the cost and performance, the cost of the project and the performance of the product should also be considered. So, these are some key points you should remember when you are deciding that whether the software engineering is a science or art. When you should have the clarity of when I am talking about science, how the science is implementing, when I am talking about art and how the art is implementing. Then first one is comparison with other discipline. First thing what you have to compare with the other discipline. Second one, empirical and systematic basis. Empirical means historical data. If historical data is not available, then you have to follow the guidelines. Then next point is scientific approach. Where if it is art or science, you have to decide. That's what they are saying, science or scientific approach. Then handling the conflicts. So, in summary, software engineering is a blend of science and art, combining systematic methods with the creative problem solving and practical experience. So, finally what we want to say is like, when I am talking about software engineering, it's a blend of all the things. Like it is an art, we can say it is a science, and blending of this art and science, we make it as a software engineering principles. Okay, which contains some problem solving technique and with a practical experience. Now, evolution of an art into engineering discipline. From art, before slide, if you see that just we are deciding whether it is a science or an art. But we are concluded that finally, okay, in order to develop software engineering principles, there we need to have both the blend of science and art. Okay. Now, coming to the next slide, where we are explaining that evolution of an art into an engineering discipline. So, here we are saying that first of all, you think or decide whether it is a science or art. The next thing is, if it is science and art, then blindly what they are saying is like just blend both science and art, and then it will develop a software engineering principle. Now, in order to blend it into a software engineering principle, there we need to have to follow some three categories. The one is 1.1.1, where evolution of an art into engineering discipline. Now, software engineering has transitioned over the past 60 years from the informal art to a structural engineering discipline. Early programmer methods such as ad hoc, exploratory, build and fix, and code and fix relied on institution and lacked formal guidelines. So, software engineering has a transition over past, as I already told you in the very beginning of this class, like evolution was not done in an overnight day or in a matter of 3 to 4 days. It was like 60 years of struggle where they have sorted out the problems and they have designed this software engineering principles. When we are talking about 60 years of past, then informal art is structural engineering discipline. Informal art means simple programs which are written like a small program to develop some prime number or odd even number. From there they have started the development process to a engineering discipline. Later on, from that they have developed into a programs. Now we are developing machine learning, full stack web development, e-commerce platform projects, or a banking application project. From there to there we have traveled for 60 years. Now, in these early programming methods, when I am talking about 60 years, means there are early programming methods. The methods called as ad hoc, exploratory, and build and fix, and code and fix. So, these are all the methods generally what you students do in our college. Like ad hoc means the old type of style where in order to sort one problem, there we need to write some 1,000 lines of code. That is ad hoc style of program. There is no question of any logically implementation like for loops or do whiles like that. Simply to sort out or to write two numbers, it's all about a COBOL program where if you want to calculate a plus b equals to c, then you have to write some multiple lines of code. That is the ad hoc style, where exploratory style is generally like a build and fix model, where you are building and fixing. If something happens, again you have to go inside the source code and rectify the problem and fix it. This is like iteration process until and unless you get the output. So build and fix and code and fix, code, write the code and fix the problem. So these are all what mainly depend upon the on the institution and lacked formal guidelines. So in the previous model, when I'm talking about evolution of an art into engineering, before that, just simply they don't have any that much of knowledge. They lack the knowledge of formal guidelines. The guidelines like what we used to develop in the Java type of program, where some import statement should be there, imports are the packages. So that type of programming style was not there. So that is one drawback we can see. Then build and fix style, as I told you, programs are developed quickly without detailed planning or design. There is no question of detailed plan, just requirement has been collected from the client. They started writing the program and they develop it. It is not enough. If a program contains like if they want to develop for 100 students, it is okay. When it comes to develop a project for 1,000 students, then it is highly impossible if we follow this build and style. Next one is defects and imperfection with identifiable and corrected later. So defects and imperfections were identified and laterly it was corrected. What is meant by exploratory style? So common for a new programmers resulted in low quality, unmaintainable and expensive code. The evolution reflects the need for structured, principle-based approach in software development to ensure quality and maintainability. So exploratory style is common for a new programmers. This is not for, as I told you, there are good programmers and bad programmers. Bad programmers doesn't mean that they don't have any knowledge. It means that they are the newcomers or the new programmers. They don't have much knowledge about the programming skills, which may result to the low quality, unmaintainable and expensive code. Like the code was also very expensive. The evolution reflects the need for, so these drawbacks made them, there should be a proper structure. If I'm keep on doing this model, then when I can develop application which contains some thousands of records, or application like Aadhaar, where some crores of records are to be implemented, then if I'm doing this model like exploratory or build and fix style, it is highly impossible. So there is a need for structured principle-based approach in the software development to ensure quality and maintainability. There should be a quality and it should be in a maintainable manner. So that is about first thing of an art into engineering discipline. Second is evolutionary patterns for engineering discipline. So evolution not only from art to engineering, it has been moved to patterns. In order to develop the engineering disciplines, there we need to have some patterns. Patterns are what? Some designs. So some designs are needed in order to develop the software engineering. Evolution of software engineering mirrors the general patterns of technology development, transition from esoteric art form to a craft, and finally emerge as engineering discipline. So this esoteric form where it is from the art they got from the traditional, like from their ancestors, what they developed, the programming style, to an craft, and finally merged as an, they have crafted it from art, they have crafted with their skills. The programmers with their minimum knowledge, they have started writing the program, and then they have implemented some small logics, they have crafted it, and finally they made it as engineering discipline. General patterns of evolutions are what? Similar, I told you, like in the pottery making, in the same manner they are explaining about iron making and construction. Software followed a pattern. Initially, knowledge was limited to few experts. So it was like only up to a good programmers who have the knowledge of developing the software engineering or developing the program or a project. Over time, it has become a craft where knowledge was shared and passed on systematically. Over a period of time, this knowledge has been shared, and knowledge was shared from the good programmers to the follower programmers or the new programmers in order to develop in a systematic manner. With the introduction of scientific principles and systematic organization, it became a structural discipline. Now, in the previous slide, we have seen that there is a need of structural discipline. When I am talking about patterns, they have implemented that patterns, so which may lead to develop this structural discipline. So we can explain this with an example of iron making. In ancient In ancient times, only few knows how to make the iron. Then the transition from family guarded secrets to systematic documentation and incorporation of scientific modern to steel making. Now, steel making companies, like previously, how they used to develop this method of making iron, it was from their ancestors. They started developing small vessels. Then later on, with the development of their knowledge, they have transitioned from their family guarded secrets to, they have made it in a systematic approach with the help of some documentation. How the systematic approach will be developed? With the whatever they developed in their past, they have made it as a documentation, and this documentation are incorporated with a science and technology. Later, it has been given their foundation for the modern steel making fact. Now, coming to the parallel in the software development, early software development had, as I told you, they are good programmers following certain principles and bad programmers lacking structured knowledge. They have good programmers are the deciding factors who will decide how to write the program, how to conclude the program, and how to execute the program. Just bad programmers are, they don't have, they do have knowledge, but the structural, how to structure the program, how to document the program, how to utilize the program, they are lacking that knowledge. Then principles of tricks known to good programmers were seldom shared with others. So the tricks are very rarely, like good programmers, they have the knowledge, but they very rarely share the tricks to the upcoming or the new programmers. Then over a time, research and organization transfer this principle into structured body of knowledge. Then over years are passed away. Then later on, what they have done, this good program, and they started documenting the things. Like whatever they do in a programming, they started writing all the things manually or in a Word document and documented all the process. So this documented process may help them over a time transform these principles into structured body of knowledge. Then they finally made one structure. So in order to develop one project, you need to have some structure, and which means before going to the software engineering, they just think like they want to structure the documentation or they want to structure the knowledge. Program writing evolved in engineering discipline, blending practices, methods, and scientific insights. Programs evolved into an engineering discipline. Then later on, after structuring the knowledge, the programs are evolved in an engineering discipline and blending practical methods with scientific insight. They started structuring the things, and later on they started developing the program with the structured documentation knowledge into engineering discipline, then blending the practical methods, what are the practicality they have learned so far, with the scientific insight. The systematic growth and incorporation of best practices have shaped software engineering into formalized discipline similar to others. So this method, the systematic approach or the pattern based approach, made them to develop a best practice, shape the software engineering into a formalized discipline, which makes a sense. Like now the engineering discipline, like other civil or mechanical engineering sort of things, here also they started developing engineering discipline patterns in the development process. Now, blending of science and engineering. Now, last thing in the last slide, what I told you, like they just blend the art and science together to form the engineering discipline. Here, finally, what they are concluding is software engineering shares the characteristics with engineering and science, and also it includes the artistic element. So, finally, you should make it clear that in order to develop the software engineering, there you need to have the art and science together. They make the final output of software engineering. So, it really heavily on systematic organized knowledge gained through the experience of numerous practitioners. Systematic knowledge gained from the experienced, like what I told you, good programmers, from their experience, from their documentation of the numerous practitioners, which may lead to the blending of all these things. Then systematic and rigorous approach. Theoretical foundation oftenly support empirical observation, and in case lacking of theoretical banking, practical experience guiding the process. So, theoretical foundation oftenly sometimes support empirical observations. Empirical observations are the historical observations, where this oftenly, and in case lacking theoretical backing. So, sometimes this theoretical knowledge may not be that much enough to found the solutions for the problem. So, practical knowledge is very important. So, practical experience may guide to the process. Then scientific solution in software engineering are constructed through rigorous and probable principles. Rigorous is what continuous development of the process. Like these programmers continuously from past 60 years, they started developing with the probable principles, like they develop some techniques, some science, and they develop some principles, some engineering principles in order to develop this process. Then conflicts, goals and trade-off. So software engineers frequently deal with conflicts goals like cost, maintainability, usability during problem solving. Multiple solutions are proposed and considered to select the most appropriate. Already we have discussed this point, like there are conflicts, goals and trade-off. Achieving the final solution often requires several iterations and backtracking. So in order to finally obtain the end product or the end project, the number of iterations and backtracking has to be performed. While science typically aims for a unique solution, software engineering often evaluates multiple alternatives before arriving at vibe, and final solution will be taken from applying this scientific approach, where it typically aims for the unique solution that depends upon different projects. Like a solution for banking application will be different, solution for a e-commerce application will be different. So in order to obtain this viable solution, unique process has to be obtained by implementing the software engineering principles. Then principles of engineering versus art. So engineering disciplines include software engineering rely on well understood and well documented principles, as I already told you. Like it needs some documentation. Every part of the each and every phase of the project needs some documentation. So this finally what we have to understand from this overall process is this engineering discipline includes software engineering mainly depends upon understanding the concepts of patterns and as well as the documented principles. Then art, on other hand, involves subject to judgment on the qualitative attributes, oftenly using less formalized principles. When I'm talking about art, means art doesn't take any technicality. It's all about like our ancestors. They got their knowledge from their past experience. It involves only subject to judgment, the judgment of about their subject, their knowledge, and based on the qualitative attributes. So whatever the advantages, whatever they earn the knowledge, the qualitative attributes, oftenly using less formalized principles. There is no question of technicality. It has the knowledge they have gained from their ancestors. So this is about evolution pattern for engineering discipline. Already we have seen all the points, we have covered all the points, like how it has been conformed to a patterned model. Then coming to some graphical representation where we can explain the time and the technology from art to craft and craft to engineering. When it was an art, it was only esoteric use of past experience. As I told you just now, it is all about the past experience. Our ancestors from their childhood, they started doing what we have seen in iron making or the steel making process. This is an only art. Then later on, from that art, with their experience, they made it into a craft. They have crafted with their experience, unorganized use of past experience. They have not documented anything. Simply with their ancestors' knowledge, they started crafting the knowledge. Then from that craft, they have set it to an engineering discipline, where engineering discipline means what? You have developed this art to craft into systematic use of past experience and formulation of scientific basis. So systematically, there was an organized structural format in order to develop a software process. It is a systematic use of past experience. This past experience, we are getting this past experience from this art and craft only. Now, past experience and formulation of scientific basis. So together, this art and craft, finally, what I want to conclude is, in order to develop a software engineering principle, there we need to have this art and craft together. They have blended into engineering discipline. The over period of time, it has been changing from here, from past 60 years of travel. We have seen in the evolution from very starting to current to 2025, we have seen the engineering principles from art, craft to engineering. Okay, thank you.